Managers of highway construction programs face complex problems administering a wide range of activities. Construction management covers activities such as surveying, inspecting, quality control, documenting payments, and related field activities. As a result of the complexity of the work, there is a need for a comprehensive construction management system, which can be adopted for use by highway agencies. In this course, we will provide an overview of the Construction Management System, or CMS. We will identify the basic functions of construction management and present information on how to develop a construction management system. The major elements of the CMS are planning and staffing, budgeting, scheduling, monitoring, and system updating. This program will provide an overview of the entire CMS. The following 4 tapes in this series provide details on each of the major system elements. Implementation of a construction management system can result in a number of benefits, such as lower cost and increased efficiency of the overall construction program, streamlining of management processes, improved timeliness of contractor payments and project finalization, and automation of and increased access to critical construction information through reporting functions. The CMS elements are modular in design. Each element may be used by itself or as a part of a complete system. The elements are flexible. They can be modified. Guidelines provide for adapting the system to local needs. The planning and staffing element defines manpower requirements, how many employees are needed, and when they will be needed. Staffing needs may be tabulated by contract, by engineer, by sub-district, or by district to determine the number of employees required. Skill level requirements may be defined to determine the numbers of technicians needed in each grade. In the planning element, the number of man-hours and man-months are determined. Standard planning values are determined for each contract type and multiplied by the number of units involved, resulting in total man-hours required. The total man-months required are determined by dividing total man-hours required by available man-hours per month. The monthly needs are determined by distributing the man-months over the contract period. In the budgeting element, the manpower needs determined in the planning and staffing element are priced out, using standard costs to develop a program budget. This provides realistic cost estimates for performing the construction management work for the anticipated construction program. The man-months from the planning element are multiplied by standard costs. The scheduling element provides for short-term, typically weekly, assessment of staffing needs to react to the contractor's plans, weather conditions, and employee availability for effective use of personnel. The process involves listing the work to be done, assigning personnel, comparing needs with available personnel, and advising districts or other areas of excesses or deficiencies in personnel levels. In the monitoring element, the actual man-hours used are compared with those planned and with the contractor's progress to allow engineers to assess their effectiveness in utilizing their employees. The monitoring procedure compares actual man-hours used with contractors' progress. This is done by dividing man-hours used by planned man-hours to determine percent of man-hours used. Next is system updating. Guidelines detail reviewing and updating the system annually. You also need to consider several other factors. First, select an implementation organization. You will also need to develop a plan for system design and implementation. Investigate work methods improvements, and consider numerous data processing decisions. Adapting and implementing the system is a one-time effort and requires a full-time staff as well as a firm commitment from top management. The person who will operate the system should be on the implementation team to ensure complete familiarity with system design. It is recommended that the implementation organization include a steering committee, a technical panel, and a project staff. The project staff should be assigned to the construction engineer. Responsibility and authority for construction quality assurance and for staffing construction projects should not be separated. Throughout the system development process, a conscious effort should be made to involve all levels of personnel in the organization. A steering committee should be selected to guide the project. The committee's duties include establishing the framework within which the project will be carried out, reviewing and evaluating project progress with special attention to matters that cause delays or difficulties, reviewing and evaluating major findings, analyses, conclusions, and recommendations for completeness, logic, consistency, and practicality, ensuring that the project is fully supported at the central office to expedite implementation, evaluating final system design characteristics, and recommending actions needed for implementation, and ensuring that the system is implemented and supported by the field construction supervisors. The steering committee should consist of 4 to 6 top management officials. Suggested members are the chief engineer, the chief of operations, the construction engineer, the personnel director, and the head of computer services. The technical panel should consist of 4 to 6 agency personnel who are very knowledgeable about current construction operations. The panel will work with the project staff on a part-time basis in adapting the various components of the system. Panel members should be selected to represent various geographical areas: urban, rural, flatland, and mountainous areas. Panel memberships should include a mix of engineers in charge, area construction engineers, district construction engineers, and assistant district construction engineers. The project staff will be responsible for successfully implementing the system. The staff should include a full-time engineer to provide direction to the work, and a full-time assistant engineer to assist in adapting the system and training field crews. Once the system is fully implemented, the project staff can typically be reduced to one full-time construction staff engineer and a full-time clerk typist. The technical panel is used annually to assist with reviewing and updating the system. Someone at the chief engineer level should select the implementation organization. Recommendations for the project staff and the technical panel can be made by the chief of operations, construction engineer, or other appropriate officials. Next, you will need to develop a plan for system design and implementation. The plan should allow for collecting available data on the current workforce, construction programs, and personnel classification plans. Computer time available, current turnaround time, and priorities should also be checked. The plan should provide for modifying the elements selected from the model system. The system should be implemented in one district first to fine-tune the system. Implementation should proceed as quickly as possible after the first area has been implemented satisfactorily. You will also need to investigate work methods improvements. There is a need for continual evaluation of methods, equipment, and materials. Paperwork is often started to correct specific problems, but is continued long after the problems are solved. Departments must eliminate wasteful, outmoded practices. It is important to expend most of the effort in work methods improvements on those activities which require significant amounts of manpower. A 5% statewide reduction in office work for earthwork quantities would result in a significant savings in most departments, while a 50% reduction in office work for asphalt paving would yield very little savings in manpower. Efforts should be concentrated where the potential for improvements is the greatest. There are many data processing considerations to resolve. Each agency must assess its own computer capabilities. There are many variables to consider in distributing the man-months over the calendar year. Engineering judgment is the best method for considering all of these variables. If the planning computations are computerized, budgeting would logically also be calculated on the computer. It may be possible to save programming time by using or adapting existing software. There are two sources of program information: the American Association of State Highway and Transportation Officials, AASHTO, and the Highway Engineering Exchange Program, or HEEP. The American Association of State Highway and Transportation Officials prepares a computer systems index. The index is updated annually. It is available from AASHTO at the address on the screen. The Highway Engineering Exchange Program, HEEP, encourages members to share systems and programs. Information about HEEP may be obtained by contacting the president of HEEP at the agency shown on the screen. In this program, we have provided a basic overview of a typical construction management system. As you will recall, the major system elements are planning and staffing, budgeting, scheduling, monitoring, and updating. For more information on this or other IRF videotapes, write to the International Road Federation or call the numbers on your screen. The objective of the planning step is to estimate the total manpower required to perform field construction management functions. Decisions must be made as to how far in advance to plan and what methods to use for planning manpower needs. Planning may be confined to the current year or be done for future years as well. How far in advance effective planning may be done will depend on the reliability of the construction program. Planning for manpower requirements for future years shows the trends for the number of employees needed to handle the work programmed. Knowing the trend allows time for training, transfers, recruiting new employees, or reducing forces through attrition rather than by layoffs. The planning method should relate the work to be done, staking, inspecting, and documenting, with the needs in the contracts. The planning methods selected will depend on the amount and reliability of data available. Consideration should be given to the type and size of contracts normally awarded. A recent analysis of selected highway construction contract awards showed that 29% of the contracts were for amounts in excess of $500,000. These contracts represented 84% of the total dollars obligated. These contracts will require the bulk of the construction management staffing. Projects of this size require more lead time for design than smaller ones. 3 planning methods have been developed, depending upon the level of available data. They are based on defined contract quantities, defined contract limits, or programmed dollar amounts. The method selected should provide a reasonable degree of accuracy and be based on the best contract information available. First, let's look at planning based on defined contract quantities. This planning method provides the most accurate manpower projections. It should be used when detailed contract quantities, such as tons of asphalt paving or bridge span lanes, are known. This method relates the contract quantities to specific activities. Next is planning based on defined contract limits. This is the next most accurate method. It should be used when contracts or programs are at least defined in terms such as roadway miles, but when detailed quantities are not available. This method relates the contract limits to activity groups. The third method is planning based on programmed dollars. It is the least accurate method. It should be used when the only known information is the estimated cost. The dollars are converted to contract limits, such as roadway miles, by means of cost standards for each contract type. Next, you will need to select contract types. The number of contract types used should be the minimum number needed to distinguish contracts. The grouping of contracts should be based on type of construction and contract characteristics. Only those contract staffing similarities representing a major portion of the construction workload need to be identified as contract types. Smaller jobs may be handled by grouping them into a miscellaneous contract type. Large, unusual jobs command special considerations in a unique classification. A general guideline may be followed when selecting contract types. The number of significant contract types should represent approximately 75% of the number of contracts and about 90% of the dollars in the construction program. Also, contract characteristics affect the progress of the work, and therefore the manpower requirements. Major factors include the difference between rural and urban locations, terrain, mountainous or flat, and working with traffic control through the work zone. 2 master lists of contract types have been compiled. One list for planning with detailed contract quantities, and the other list for planning when only major characteristics of the contract are known. Both sets include major contract types as well as minor contract types, which represent significant portions of the workload in most areas. Each agency should evaluate and modify these lists in relation to its construction objectives. Only those contract types which best describe the workload should be used. Smaller contract types, which are used infrequently, should be included with miscellaneous contracts to keep the number of types to a minimum. Once contract types have been selected, planning activities must be determined. Planning activities are used to define work that must be performed by field construction personnel. 2 sets of planning activities have been developed to define engineering work for any construction contract. They are developed for individual activity or by activity groups. The level of construction detail will determine which set should be used. Individual planning activities should be used whenever detailed contract quantities are known. The number of activities used should be the least number that will provide sufficient detail for reasonably accurate planning of the workload. Over 300 separate activities have been identified in some agencies. However, 80% of the total man-hours used in those agencies were on about 35 activities. The remaining 20% can be combined in miscellaneous activities. A master list of typical activities has been compiled. It is intended to cover the significant activities for most agencies. Each agency should modify this list to fit its own work methods. Planning units of measure are used to relate construction work requirements to the scope of the construction contract. Planning units of measure must be selected for each planning activity or activity group. The units define the engineering work required for each activity. Work requirements are related to the characteristics of the contract through the planning units. Most individual staking activities are related to the linear characteristics of the roadway, stations, or roadway kilometers, while inspection activities are generally more dependent on the contract quantities. Quantities should be readily obtainable from contract plans or other existing work documents. For example, if asphalt paving is paid for by the ton, use tons. Roadway kilometer is the linear length of a roadway of independent or relatively independent alignment. Multiple lane, divided, or undivided highways are considered as two roadways. 7,500 cubic meters is a bid item quantity, which is used for earthwork inspection and testing on construction contracts. It includes excavation, embankment, subbase, and all other earthwork on the project. 1,000 metric tons is a bid item quantity, which is used for asphalt paving inspection. 1,000 square meters is a bid item quantity, which is used for Portland cement concrete paving. 100 square meters is a bid item quantity, which is used for joint repair on Portland cement concrete pavement. Span lane is the number of spans multiplied by the number of traveled lanes of each structure with a clear span of 6 meters or more. It is used for structure inspection on major contracts. Bent is the number of substructure abutments or pier locations. It is used for structure staking on major contracts. Span is the number of spans on a structure with a clear span of 6 meters or more. It is used on bridge repair contracts. Lump sum is used for special features on major or unique contracts. Working day is the number of working days estimated for the contract to be completed. It is used on the minor contracts, intersection improvements, and landscaping. There are also recommended planning units of measure for activity groups. For roadway construction, use kilometers. For bridge construction, use 30 linear meters. and others include working days and lump sum. Activity groups should be used when only major contract characteristics are known. Their primary use will be with small contracts, those which require very little time in the pre-construction stages. The groups consist of the 4 functions of construction management. They are staking, inspection, office engineering, and project management. In this course, we have covered the planning element of designing a construction management system. The objective of this element is to estimate the total manpower and other resources required to perform field construction management functions. 3 planning methods are typically used. They are based on defined contract quantities, defined contract limits, or programmed dollars. When selecting contract types, follow the general guideline, which says the number of significant contract types should represent 75% of the number of contracts and about 90% of the dollars in the program. When selecting planning activities, keep in mind that typically 80% of total man-hours used are used on about 35 to 40 activities. The remaining 20% are best combined in a few miscellaneous activities. For more information on this or other IRF videotapes, write to the International Road Federation or call the numbers on your screen. In this program, we will cover the development of staffing guidelines and planning values. Staffing guidelines are important. They are used in establishing standard planning values and in assigning personnel to field contracts. Minimum and maximum staffing guidelines are used to reduce understaffing and overstaffing. For the best utilization of available personnel, each contract staff should be made up of the smallest number of personnel that ensures quality construction. Maximum staffing guidelines show the maximum number of personnel that should normally be assigned for each operation on major contracts. The guidelines are for peak operations. The number of personnel would be less for minor contracts, and at other times when the contractor's productivity requires only part-time inspection. Each agency should modify the maximum staffing guidelines to fit its own work methods. Contract assignments, which are never performed by field construction personnel, should be omitted. Examples include the survey crew, if staking is done by the contractor, plant inspectors, when certified plants are used, and density and gradation inspectors, when the tests are performed by district personnel. The many different contract situations make it difficult to establish effective and meaningful minimum staffing guidelines. However, an outline of major work items for each contractor operation and the type of attention required, one-time, intermittent, or full-time, can be developed. Standard planning values uniformly quantify the work which must be performed by field construction personnel in construction management. Standard planning values can be established to provide guidance in determining construction management requirements regardless of contract or program status in any budget period, as long as there is some definition of the program. Two sets of standard planning values are typically used in planning. The two sets of standards are for individual activities, approximately 40 activities, and activity groups, 4 groups. The accuracy of the planning values varies with the degree of sophistication in defining construction management activities and the data available about the contracts or construction programs. Planning standards provide the most accuracy in manpower planning. A standard planning value is developed for each of the individual activities in the master list. The standard planning value is composed of a base planning value and modifiers, or additives. The base planning value represents the construction management effort per unit of measure on a normal construction project. Modifiers reflect additives to the base planning when conditions significantly affect manpower needs. Planning values should be established to a level of accuracy that ensures reasonably accurate manpower projections or needs at the district level. There are many variables in construction. It is not practical to plan for all the variables. So planning values, even with the use of additives, do not have to exactly satisfy the manpower requirements of an individual contract. Final adjustments to manpower requirements among the contracts in a district can be accomplished through scheduling techniques. A number of guidelines apply when planning standards for activity groups. Detailed quantities are not always available for all contracts. Only major characteristics of the contract may be known. Under these circumstances, it is not practical to use all activities. Detail should be reduced to that warranted by the accuracy of the data available. Activities were combined into 4 groups: staking, inspection, office engineering, and project management. The planning standards were developed by combining the standards for individual activities. These standards provide reasonably accurate guidelines, but they do not relate manpower requirements to contract characteristics as accurately as standards for individual activities. Modifiers to the planning standards may be desirable for some agencies to provide more accurate estimates. Only 3 construction conditions have significant effect on manpower needs in most agencies: working under traffic, construction in urban areas, and mountainous terrain. Developing standards for activities involves adapting base planning values and modifiers. The process for developing base planning values includes reviewing the standard planning value computation sheets for each contract type, selecting the sheets applicable to the selected listing of contract types and activities, reviewing the significant work tasks within the standard planning value documentation according to the previously revised activity definitions, adjusting tasks, construction quantities, productivity values, testing frequencies and inspection time on all activities where necessary, completing new planning value computation sheets and computing base planning values, and compiling base planning values on a table of activity planning standards. Using modifiers involves re-evaluating the new standard planning value computation sheets for each of the modifiers selected, adjusting tasks, construction quantities, productivity values, testing frequencies and inspection time to reflect the effect of each of the modifying factors, computing a modified base planning value for each modifier type, computing the modifier, additive percentage, by dividing the difference between modified base planning value and the normal base planning value by the normal base planning value, and adding the modifier values to the table of activity planning standards. Developing standards for activity groups is next. If these standards are selected, modifications must first be made to the standards for activities. Then you will need to adapt the base planning values for activity groups. Selecting the base planning values involves reviewing the activity group standard planning value computation sheets for each contract type, selecting the sheets applicable to the adjusted listing of contract types, reviewing and adjusting the activities and their base planning values from the table of activity planning standards, which would normally be used on a typical contract, adjusting the quantity estimates to better reflect normal construction contracts within the agency, completing new standard planning value computation sheets and computing base planning values, and compiling base planning values on a table of activity group base planning values. Using modifiers for activity groups involves re-evaluating the new activity group standard planning value computation sheets for each of the modifiers selected. Increasing the base planning values of the activities by applicable modifier percentages from the table of activity planning standards, computing a modified activity group base planning value for each modifier type, computing the activity group modifier, additive percentage, by dividing the difference between modified base planning values and the normal base planning value by the normal base planning value, and compiling modifier values on a table of activity group planning modifiers. For some construction programs, neither detailed quantities nor defined project limits have been established, but program budgets are available. Where this is the case, manpower requirements may be estimated by using dollar conversion standards. The cost per planning unit is estimated. The dollars are converted to equivalent planning units, and man-hours are planned using the standards for the planning activity groups. Nearly all major contracts would have quantities and defined limits available for the current budget period, and most would have them available for 3 to 5 years prior to construction because of the lead time required. Some construction programs, such as overlays, usually are defined only in terms of dollars until shortly before contracts are advertised. Where any construction work is defined only in dollars, for whatever reason, it is necessary to convert dollars to the units of measure for activity groups. By converting the program dollars to contract units, the manpower standards for the activity groups may be used. This avoids the need to develop and update another set of manpower standards. These standards simply convert construction dollars to contract units, roadway kilometer or linear meter of bridge. Dollar conversion standards provide an estimate of how much may be constructed with available dollars. Dollar standards by themselves are not used in planning. They provide the units to be used with the standards for activity groups. Standard costs per planning unit are developed for each contract type. The costs should be based on current bid prices with an allowance for inflation or other anticipated changes. For example, if overlay project average costs were $25,000 per roadway kilometer, a district overlay program of $400,000 would convert to 16 roadway kilometers. In this program, we have covered development of contract staffing guidelines and planning values. Staffing guidelines are important. They are used in establishing standard planning values and in assigning personnel to field contracts. For the best utilization of available personnel, each contract staff should be made up of the smallest number of personnel that ensures quality construction. Each agency should modify the maximum staffing guidelines to fit its own work methods. Standard planning values uniformly quantify the work, which must be performed by field construction personnel. Two sets of standard planning values are typically used in planning: individual activities, approximately 40 activities, and activity groups, typically 4 groups. For more information on this or other IRF videotapes, write to the International Road Federation or call the numbers on your screen. The next phase in the construction management system design and development is budgeting and scheduling. The actual mechanics of planning should be organized logically and systematically. This involves adaptation of standard planning values and development of dollar conversion standards. Manpower is planned by activity or activity group for each contract or program. Planned manpower may be computed in terms of man-hours or man-months, regardless of planning method. The basic computation is standard planning value times number of planning units equals planned manpower. Computations should be made for each applicable activity and totaled to determine the total needs for a contract. The recommended procedures are based on determining manpower requirements for 12 calendar months. It may be better for an agency with a 2-week pay period to adopt a system that uses calendar months, 12 per year, for future year programs, and 4-week periods, 13 per year, for current year programs. The next step involves selecting a staffing method. The staffing method distributes the manpower needs over the calendar year by estimating the requirement for each month. For any contract or construction program that can be planned for a particular budget period, the number and types of personnel needed can be estimated with varying levels of accuracy. Several options are available. Decisions must be made concerning activities to be used in staffing and manpower distribution methods. 2 types of activities can be used for determining manpower requirements: either planning activities or staffing activities. First, let's cover planning activities. Manpower may be distributed by estimating the monthly needs for each planning activity. Combining the man-hours for related planning activities will simplify the distribution. On minor contracts, such as bridge repair, the individual planning activities may be grouped into a single staffing activity. There are several manpower distribution methods: equal distribution, prorating, and engineering judgment. Equal distribution distributes manpower equally to each time period. The proration method recognizes the variance in the number of days that are actually available for construction work in the time period. The distribution of manpower can be based on the average number of charged working days. Distributing manpower by engineering judgment is primarily based on previous and present contract experiences. Manpower staffing needs can be estimated in terms of total number of personnel only. Determination of staffing needs by total numbers of personnel is adequate for each contract or group of contracts under the responsibility of an engineer in charge. Manpower needs by skill levels are desirable for district or agency-wide staffing. This technique aids in determining adequacy of existing staffing levels by skill level or specialty. The objective of a manpower distribution procedure is to estimate the manpower needs for each month. Planned manpower is distributed for each contract. It should be distributed by monthly time periods. Manpower should always be distributed over the length of a contract. Balancing monthly manpower requirements determines the total needed by comparing the number of personnel available with the number needed. The need for seasonal or part-time employees can be determined. Manpower should be balanced at the management level, which has a relatively stable need for personnel, usually the district. Transfers of employees between contracts and engineers in charge help meet fluctuating needs. Manpower requirements should be reviewed for the district each year. An allowance must be added to cover holiday, sick, and annual leave. A comparison of permanent personnel versus the monthly needs will show the excesses and deficiencies in staffing. A review of monthly manpower estimates helps in determining the need for seasonal personnel and the number of permanent personnel available for other work during the off-season. The use of planned overtime should be considered to meet peak construction needs. The advantages of using overtime include continuity of inspection and a smaller workforce during slack periods caused by bad weather. Skill level guidelines are developed to provide a basis for determining the number of employees in each classification. The guidelines are used to develop long-term personnel goals. Most activities include tasks with varying levels of difficulty. The most efficient performance of these activities is accomplished by a combination of different construction personnel. Skill level guidelines are most useful when the majority of employees in any classification are able to perform all tasks assigned to their level. Some departments have classification plans which encourage versatility. Many do not. With classification plans based on ability to perform several tasks, skill level percentages can be applied to determine the number of employees needed in each classification. The classification plan could be revised to relate to skill levels. Activities and tasks may be classified using only 2 skill levels to determine the number of permanent and seasonal employees needed. The number of employees in each specialty, such as asphalt plant inspector, may be determined. A procedure for determining skill level requirements provides a way to estimate staffing requirements by personnel classification. The number of personnel needed in each classification is determined by applying skill level guidelines to the distributed manpower requirements. Computations are made for each activity and totaled to determine a profile of skill level needs. It is not necessary to make computations for every month. Computations should be made for key months in the calendar year. The key months should represent the highest and lowest manpower requirements. The skill level requirements represent the ideal mix of employees. Actual staff capabilities may not meet the optimum requirements. Staff as close to the ideal as practical. A budget is developed to plan for the costs of construction management. Construction management costs can be budgeted by contract with sufficient accuracy using standard costs. The basic computation is as follows. Total man-months times cost per man-month equals total cost. Computations should be made for each applicable contract and should be totaled to determine the required budget. The budgeting procedures are designed for manual computation, but can also be done by computer. Standard costs are developed to simplify preparation of budgets. The standard costs should allow for labor and other expenses necessary for contract support. Labor costs should be based on the actual average annual salary paid for each classification. These costs should contain base pay, fringe benefits, and any anticipated pay raises. An additive can be computed to allow for estimated overtime costs. Scheduling is done to assess short-term manpower needs, to plan personnel assignments, and to communicate assignments to employees. Managers, and construction engineers are managers, must schedule to effectively and efficiently use personnel. Even where scheduling is now done, schedules are often not written. In some instances, this works, and crews are used effectively. Scheduling procedures should be simple and allow for listing the work to be done and assigning personnel to perform the needed work. To meet the objectives of scheduling, you must consider what work needs to be done, the means of assigning manpower, and how to communicate the plan. This involves adoption of standard planning values and development of dollar conversion standards. Manpower is planned by activity or activity group. Planned manpower may be computed in terms of man-hours, man-months, or other time periods. Manpower can be distributed using either planning activities or staffing activities. Also, there are a number of manpower distribution methods: equal distribution, prorating, and engineering judgment. In this program, we have covered the procedures for manpower budgeting and scheduling. For more information on this or other IRF videotapes, write to the International Road Federation or call the numbers on your screen. More information on this or other IRF videotapes, write to the International Road Federation or call the numbers on your screen. The next phase in the construction management system design and development is system monitoring and updating. For every objective, there must be a way to measure accomplishment of the objective. The work monitoring method provides for evaluating work performance, staffing, and construction progress, and for making staffing adjustments when necessary. It also provides data for updating standards. Construction management performance on each contract should be monitored and controlled by the engineer in charge. Higher levels of management should monitor manpower usage and work accomplishment through exception reports and summaries. A work monitoring procedure should provide only needed, timely information appropriate to each level of management. Excessive reporting should be avoided. Monitoring of construction management usage requires a comparison of planned manpower with that actually used. Proper data collection is important. Assigning qualified individuals and developing well-organized data collection is critical. The most effective work monitoring can be done at the engineer in charge level. Control by higher levels will generally be too late. Summaries and exception reports should be furnished to the districts and central office. Detailed reports are available at the contract office if district or central office personnel have questions. Work monitoring reports should be prepared at time intervals that facilitate effective management. For example, a monthly report will be of little value for controlling manpower usage for minor contracts that last only 30 to 90 days. Manpower reports must be timely. The time lapse between the close of the reporting period and completion of the report for review by the engineer in charge is critical. A week or less is ideal. The selected frequency should also coincide with that of other construction reports. If current construction reports are prepared on a 4-week period basis, then the frequency of manpower usage reports should be compatible. The work reporting process should be compatible with existing documentation. The contract status information, such as contractor's earnings and contract time, is already available in current construction reports. The only additional information required is actual manpower usage. The actual man-hours used may be reported by individual planning activity. Alternatives include reporting by planning activities, staffing activities, or one activity per contract. The use of planning activities provides more detailed information, but requires more effort than the other methods. The level of detail could be reduced even further by reporting by contract. On larger contracts, the lack of detail will make identifying staffing problems difficult. On small contracts, the inspector will be doing a wider variety of tasks, making reporting to a number of activities difficult. The use of only one reporting activity on minor contracts is recommended. Monitoring requires evaluation of the man-hours used and the work accomplished. One method includes comparing the actual man-hours used versus the total planned. Another involves comparing the contractor earnings versus the total contract cost. A third method involves comparing the percent of contract time used. Man-hours comparisons may be tabulated by planning activity, staffing activity, contract, or a group of contracts. In the reporting and monitoring procedure, manpower data are tabulated to provide for evaluation and control of manpower usage and work performance. Procedures and forms for work reporting and monitoring must be developed. Procedures must be developed for controlling by activity or contractor operation, and monitoring and controlling at the engineer in charge level. Man-hours used on each contract must be reported accurately. Reports may be daily or weekly, but the man-hours used on each activity should be recorded daily for accuracy. Existing timesheets may be modified to collect the man-hour information. The man-hours used must be tabulated to prepare the manpower status report for the engineer in charge. The activity ledger is a worksheet for summarizing the man-hours. A manpower status report provides the engineer in charge with a summary of the man-hours used. The level of detail in the reports depends on the number of activities selected. Two procedures have been developed. One is for staffing activities. The other covers the use of planning activities. In both instances, key bid items are used. The district should be alerted to potential overruns or underruns. Exception reports are submitted only when man-hour usage varies from contractor progress by more than a pre-selected percentage, such as plus or minus 15% on each contractor's operation and 10% on the contract total. Only those operations where an exception occurs need be shown on the report. The type and number of contracts to be used can change in future years. Contract types should be reviewed annually to determine their continuing effectiveness. The relative importance of the types of contracts in the work program will most likely change. The contract types used for planning should be reviewed annually by the project staff and technical panel. Data from the final manpower status reports for contracts completed during the last year should be used to determine the number of contracts by type, the number of man-hours used by contract type, and the total construction costs of each contract type. The anticipated work program should also be reviewed by contract type. The tabulation should show the number of contracts in each type to be let and total estimated construction cost of each contract type. Contract types are used to group contracts according to their similarity of staffing needs. The relationships between the man-hours used, the number of contracts completed, and the cost of those contracts will help to determine which types are significant. Work method improvements affect the planning activities and their units of measure. Planning activities should be reviewed annually to determine which activities require significant amounts of manpower and therefore should be used for planning purposes. Units of measure should be examined to see if each unit adequately relates the construction management work requirements to the scope and characteristics of each contract type. All procedures that will be used in the construction management system should be completed before developing updating procedures. The procedure for updating contract types should be completed before developing a procedure for updating planning activities and units of measure. Planning activities are used to define construction management work that must be performed by field construction personnel. Planning units of measure are used to relate the field construction management work requirements to the scope and characteristics of the contracts. Changes in the work program, specifications, and bid items may change the need for activities or units of measure. Planning activities and units of measure should be reviewed annually to ensure that current needs are met. The updating procedure should provide for evaluation of planning activities and units of measure by the project staff and the technical panel. Final manpower status reports should be used in evaluating activities. These reports can be from all contracts completed during the past year or a sampling of those contracts. The detail of data from the manpower status record will depend on the activities selected for monitoring. If planning activities were used, a tabulation of the data will identify the significant activities. If staffing activities or some other activity group were used for reporting, then the evaluation will be more subjective. Standard planning values must be reviewed periodically to ensure that they are valid for the current work program. Construction management requirements defined by standard planning values will not remain constant. Changes that may revise manpower requirements include changed work programs, improved work methods, and changed responsibilities of field construction personnel. The actual man-hours used are available on the final manpower status reports. The level of detail will depend on the activities selected for monitoring. These data will be available for all completed contracts. Average data will be of little use without appropriate evaluation. In making this evaluation, you should consider a number of things. Were good management practices used? Was the contract completed on time? Was the contract staffed properly? The best way to evaluate the standard planning values is to review the current standard planning value computation sheets. Evaluate all of the assumptions and computations on each sheet. Review the standards of the modifiers at the same time. Methods for collecting information for use in the evaluation include actual man-hours used from the final manpower status reports for all completed contracts, selective reporting, and work sampling. Obtaining data by planning activity can be done by selecting a number of typical contracts of each type. This simplifies reporting for the majority of contracts, but allows for collecting data for updating the standard planning values. If reporting of man-hours used is by staffing activities or other activity groups rather than by planning activity, comparing the man-hours used with the standard planning values would be more subjective. The variation in man-hours used per activity will also occur on the selected contracts. The range should not be as wide on these carefully selected contracts as it would be on all contracts. Actual staffing and productivity can be checked by sampling. Observations of the numbers of department personnel and the work accomplished on comparable contracts when essentially identical contractor operations are underway can be made. Post-construction reviews can be held on selected contracts to evaluate staffing, the standards, and anything which affected the manpower requirements. Participants in the review could include the engineer in charge, the designer, and the contractor. Standard costs must be updated annually to allow for changes. Inflation, pay raises, and increases in fringe benefits all affect the standard costs. The same procedure used in developing standard costs may be used for updating. Review the computations and revise the data as required. Skill level guidelines should also be updated periodically. Only significant changes need be considered. Skill level guidelines should be reviewed when changes are made. Such changes include new work methods, new responsibilities, and new equipment. In this course, we have covered the procedures for system monitoring and updating. For every objective, there must be a way to measure accomplishment of the objective. The work monitoring method provides for evaluating work performance, staffing, and construction progress, and for making staffing adjustments when necessary. A work monitoring procedure should provide only needed, timely information. Excessive reporting and paperwork should be avoided. Proper data collection is important. Assign qualified individuals. Work monitoring and manpower reports should be prepared at time intervals that facilitate effective management. The selected frequency must be considered carefully. Also, planning activities and units of measure should be reviewed annually to ensure that current needs are being met. For more information on this or other IRF videotapes, write to the International Road Federation or call the numbers on your screen.